interesting is how a lot of the media outlets are doing the mea culpas this morning on, oh, we forecasted a flood, that didn't happen, and blah, 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 blah. You know, it did happen, but it was spotty. Like the parts of northern New Jersey did pick up a foot of snow. But one thing that was really interesting with this low, and the models actually did a pretty good job with this, is that they never really consolidated this thing. It was never going to be one nice consolidated upper low, negative tilt trough. You know, so you can almost see it still. It's never really quite consolidated. It might try, you actually still have a double barrel system rolling up into the Canadian Maritimes. And I think that was one of the reasons why the snow was so spotty. And the time of year. I mean, March 21st, you got to have everything go absolutely right for the snow to accumulate. And well, things didn't go completely right. But here in State College, 3 inches ain't bad for State College. Meanwhile, out west, that's fun. We'll talk about that in a minute. Let me do visible imagery because this kind of factors into the forecast tonight. There, you know, you make out where the snow fell, right where I would say, you know, it's a pretty good darn forecast on where the snow line was. Remember how hard that northern extent was going to be, and everyone was trying to draw the line right along I-80, and it looked pretty good. But now we got some high clouds overhead with you know, a little bit of wraparound high level moisture and also a little bit of a shear axis overhead. This is going to get interesting tonight because when the winds die off and we have all this snow on the ground, the low was 26 last night. I just checked, the dew point was 19. Moss is going 25 tonight for the low at State College. I would take the under on that. Probably because Moss probably doesn't know that this snow is on the ground. Just a guess. But I would probably go a little bit lower on the low temperatures tonight. That's my kind of short-term thing. Okay, the bigger thing that's been interesting is what's going on out west. A lot of folks have been talking about this, and how many of you went to AMS? Well, you guys went, yeah, AMS. There were several talks on integrated vapor transport and how it's a really good proxy for forecasting atmospheric rivers, and we have a really good atmospheric river here, heading right into the heart of Central California with value 500 is pretty good, 750 is darn good, and 1,000 is awesome. A lot of moisture transport in California. This is only like the second storm they've had all winter long. So they're definitely going to take it, but this is obviously a lot of moisture funneling into California, and this is going to get stuck there for a good 24 hours or so. So the last rainfall amounts I saw were forecasting 10 inches. That's probably about right where things are going right now. So pretty cool out there. Here's radar, and you can see mostly, I mean, basically the whole state of California getting at least something from this. But what's interesting is that you notice this. This is actually starting to produce a divergence axis over Oregon, Idaho, and eastern Washington. They're going to get heavy rain with this too eventually. So this is kind of unusual to have a whole West Coast system. We certainly haven't seen that much this winter, but it is kind of interesting to look at. All right, let's go to the 500 millibar real quick. All right, here's our low. Of course, the depiction here is a consolidated low, but it's, like I showed, it's water vapor. It's actually in several pieces. And there's another upper level low. And of course, we've got this persistent trough that's been here for how long? A month now? It's still there. But this is a pretty dynamic system, and there's a pretty good piece of energy that's pulling out into the southern Rockies, and that should realign the pattern a little bit. And that's what the models are showing this morning. Let's go to, let's see what I want to show. Do the good old 4-panel. So watch this. We'll start up here in the upper left, 500 millibar. There's our low moving by. Look what happens here. This, I'm going to stop right there. Actually, go out here. That's that piece of energy coming out of California. And watch what happens with that. Notice it's crashing the ridge, and it actually, this is a little hard to do, is that this little shortwave is trying to strengthen as it comes over the top of the ridge. And then once it crests the ridge, and what I'm trying to say is that this is not a natural thing for a shortwave to do, but it's a strong shortwave. what that's going to mean is a very tricky forecast, probably south of here, starting, let's see, that's 12Z Saturday. Meanwhile, we're kind of in the confluence zone here in Pennsylvania, so we should be shielded from this. And it looks like that shortwave shears apart before it gets here. But this might get a little interesting. I would keep an eye on that. Right now, most of the QPF is to the south, but look at this. Yeah, looks like another snowstorm in the plains there. And you notice here we're kind of on the edge of the dry air here. Produce 78 hours on its closest approach here. This is a little tricky because you notice you don't have a really strong surface low, but you certainly have a pretty nice high. And thicknesses are, you know, a 540 or so. So this will be mostly rain, but on the northern fringe of that, that could easily be snow or something else. Meanwhile, out west, though, this trough is reloading, getting another system dropping into California. And this is where State College gets a little bit of hope. Yes. Blink and look really carefully. That's a ridge. And that's Monday, Tuesday. Now, what will happen, though, is once that ridge is positively tilted, and now you're going to have pieces of energy probably trying to lift out of this upper level low. So this should be a drier pattern, but and we're still a little confluent in here all the way out to Thursday. So it looks like next week looks pretty good until that upper level low that's over here now will eject. By the way, we haven't had this yet this year. And it is March 29th. All of you who are into mesoscale weather, upper level low down in Texas in late March, what does that usually mean?
Severe weather.
Severe weather, finally. Yeah, severe weather out. I would say that we've had quite a number of tornadoes ahead of that that complex upper level low a couple of days ago. This is going to start looking better and better for Texas going forward. So let me go to a different view. This is a website called Storm Vista. This is a website run by Matt Rogers, who graduated here from '94. He actually started his own weather company and does stuff like this, and basically repackages file data. And I'm showing this because this is the Euro model. I kind of like it because this is the spaghetti, and you can kind of see here, here we go, through 60 hours. It's kind of showing the long wave trough here. Here's 84. Notice northerly flow still over us, so this is definitely not a warm weather pattern for the next 4 days. But then we start going a little more out in time. There's that little positively tilted ridge. There's that trough in the west. But don't get too excited because the Euro is actually in very good agreement that, oh, there it is. There's the polar board again. And by 168 hours, here comes the trough diving into the Midwest. And by Easter, Easter weekend and Passover weekend and April 1st, this looks like a typical State College strato Q, back to below average temperatures, probably damp. Meanwhile, that ridge in California, they'll get their chance to dry out. And then in the Pacific Northwest, this is a really interesting pattern for us because that's northwest flow off the Gulf of Alaska. That usually means cold, crappy, rainy weather in Portland because we don't get enough of it in the wintertime. But it's also very good for us because this keeps all of our precipitation as snow in the mountains. And we actually want that this time of year because we are, on April 4th, we open all the dams up. We start opening all the floodgates up to start draining all the reservoirs out for flood control operations. So we don't want it raining when we're doing that because it's very hard to drain a reservoir when you've got inflows increasing. Water coming in faster than you can get it out, and you end up with the reservoir still going up when you're trying to get it down. So this will be an interesting pattern for us in the Pacific Northwest, but this looks like in the longer range. Yep, sorry. So Moss, 42 today, 25 tonight. Like I said, I would do the over and under on that. I'd probably go a little under, but you can notice that temperatures stay below average, and that looks really good to me for next week. And then there's that ridge. But like I mentioned, when you get into a southwest flow pattern like that, the models are trying to bring some, it depends on which model run you're looking at, but they are trying to bring systems coming northeast in that southwest flow. And that usually means at least some kind of overrunning and warm funnel type stuff. So Wednesday, Thursday look like it's pretty wet. All right, I do one more thing here. I want to show just to get a little corroboration on this. See what the GFS looks like. So this is 240 hours. I like to look at the, by the way, I'll use the eyewall page even at Portland BPA, because this is probably one of the few places I can look at every single ensemble member and go, oh, yeah, there's the ridge, trough, trough, oh, southwest flow, but trough coming in, split flow, interesting, trough, trough, oh, okay, that's a ridge, trough. You get the idea that most of the ensemble members have pretty good agreement on the individual members that that you got a 6 to 10 day period where that day 6 to 10 looks pretty good, and then you're right back into the cold weather. So that little bit of spring you're going to get next week. Yeah, another bit, a couple of days, and then it'll be cold again. Anything else? Any other thoughts and questions? And but what about? Yeah.
I have a question about your job.
Okay.
So we were just talking about the dams. Is that April 4th just for this year, or is that this target date every year?
It's a target date every year. What happens is we're setting ourselves up. Two things happen. We have to drain the reservoirs out by April 30th because that's when the peak of the snow melt will begin, and we want to have all the reservoirs empty by then, because if they're full and it melts, now you have to spill that water, that goes into the rivers, and now you're no longer controlling for floods. So basically, right now, the dams in the Pacific Northwest transition from generating electricity, because we actually don't need electricity in May, because it's one of the few times a year that it's actually nice. Well, actually, no, that's not true. We're a little cooler than that. Our highs that time of year are around 60, lows in the mid 40s, but California is the key. They don't have a lot of energy needs in April, May, but a lot of solar. So they so the electricity gets really, really cheap. And basically what we're doing is we're just spilling the water. But the second most important thing that that's for is for fish. Fish start migrating out. The salmon eggs have hatched at that point, and all those little minnows are trying to get to the ocean as fast as possible before the birds eat them, and we have sea lions parked at the bottom of one of our dams that just sit there and gobble up the fish. They're also an endangered species. So you have an endangered species eating another endangered species. That's fun. And then when they get out near the river, there's these terns that circle around that are threatened. They're not in danger, but they're threatened, so they're protected. But they're also, circling around, eating all the fish. So the faster we can get the fish out to the ocean, the better. And so we try to time the operation just right in the month of April. And so weather forecasting becomes really important. If we get a lot of water early, then we may change the flood risk operation. On 2 of the dams, we actually did that this year. We actually drained them early, just in case. Turns out we're not going to need it, but that's okay. Let's see, what else we'll talk about that. Yeah, so it's challenging every time of the year. Like during the winter time, our severe weather operation is actually, it makes a lot of sense, ice. When you're a public utility, ice on power lines is a big problem. So our folks do a lot of that, but also cold waves. If we're cold and California is cold, you have to start generating electricity at the dams, which means you're letting water out, which is fine, but the rivers are really low. There's no natural flows, there's some, but it's very little into the dams. So you don't want to let too much water out if you need it a month from now. So there's a balancing act that occurs every time we get into a cold air outbreak in the Pacific Northwest, that, okay, how much water can we let out? And that's where my group gets really important, because now not only forecasting for tomorrow and how cold it's going to get, we're also forecasting what's the weather look like in February and March. Because if it's going to be wet, all right, no problem. If it's going to be dry, oh, wait a minute, maybe we got to figure this out and what's the best operation. So yeah, so there's a lot of interesting things that we're doing on a daily basis just to balance things out. And we're also the people who get the call. We help the administrator call the snow days. So Yeah, so anytime there's a snowstorm, my email lights up from people in the building. So we're gonna get a snow day tomorrow. It's like high schoolers. You know, these are federal employees.
I've heard that.
Yeah, and I'm like, well, you know, so yeah. So that's one of the interesting things when I do briefings is that I'm always thinking. I'm not only thinking about tonight's low and tomorrow's high, but I'm thinking, what's the weather like 2 weeks from now, 3 weeks from now, 4 weeks from now. And that's a skill that, you know, if you go into the National Weather Service, usually they compartmentalize that. The first 10, you know, the first 7 days are handled by the local weather office. WPC handles that next 2 weeks, and you have Climate Prediction Center that handles so you have 3 different groups handling different segments of the weather, where when you're in a utility, you got to do that whole spectrum. And sometimes you can't get into the details you'd like to get into. So, you know, like for us, a tornado, oh, yeah, all right. Yeah, hit a power line, all right. Now for the weather weenie and me, that's really impressive in the Pacific Northwest because we don't get them very often. But from a power perspective, well, all right. Okay. Or a snowstorm, you know, 2 inches in Portland, it shuts the city down. 2 inches from a water supply standpoint for what we're going to need to run off into the reservoir in the spring, it's negligible. It's really nothing. So, never a dull moment.
How much snow did you get from Portland's one snow event this year? How much?
It was highly variable across the metro, as they typically are. Portland's an interesting place. Let me get up a. Best way to show this is a. What's this point? Great. Okay, a little bit of geography lesson here. So Portland's right here, and there's a mountain range right along here, except this little thing, the Columbia River, the gorge in here. There's a mountain range in here, so Portland actually gets less precipitation than the immediate coast. The immediate coast gets about 150, 200 inches of rain a year. Portland gets about 50. But here in the eastern Washington, eastern Oregon, Idaho, this is fairly flat terrain, and cold air likes to get trapped in there. Particularly if you get an Arctic high that instead of going east, it drops south. This can get really cold in here. And if you get high pressure east, low pressure off the coast, all of a sudden you're sucking cold air through the Columbia River Gorge right into Portland. So it gets really tricky to forecast in Portland. Not only are we, by the way, out west, rain snow line is elevation, really. It's not horizontal, it's more vertical, where snow levels are, 2,000 feet, that's hitting the Cascades and the ski resorts, and that's great. If it's down to 1,000 feet, now you're getting into the suburbs of Portland, and if you're down at 100 feet, you're snowing on Portland. And Portland itself gets 5 inches of snow a year. So we get as much snow as Atlanta. So we get any kind of snow, everyone's running out and getting the milk bread toilet paper. Oh wait, no, because it's Portland, it's vegan cream cheese, quinoa, and kale, and beer, because it is Portland. So, so when we get these snowstorms, it's all about, can you maintain the flow through the gorge into Portland before the warm air off the Pacific overwhelms the cold dome and you change to rain? And so what tends to happen is our systems end up being very mesoscale. It's rare that Portland, Seattle, like the whole entire front range of the Cascades, all of Western Washington and Western Oregon, get all snow all at once. It's usually Portland or Seattle, not both. Or it's Eugene, which is down here in the southern end of the valley, and not Portland. It's very much focused by the terrain. And same thing goes here in the Snake River Valley, here in southern Idaho. Cold air gets trapped in there. If it gets dislodged, they'll quickly go to rain. So if you think about it, strong systems tend to dislodge air masses better. So the stronger ones we don't usually worry about, because usually if there's enough mixing, the cold air breaks. The low, yeah, it'll pull cold air through the gorge initially, but that warm air just overwhelms the cold air really quickly. It's the weaker systems we have to worry about in the West, because you get just enough cold air, everything's in balance. You have just enough cold air getting pulled west, you have just enough overrunning off the ocean, and then it's snow. So my house got 5 inches. The southern suburbs got rain because they were They were away from the gorge, and my house is in the northeast part of Portland. But we had some hills around Portland that got 9 inches. And it was over 20 miles, 30 miles. So.
You guys are kind of the West Coast hub for freezing rain as well. Have you guys had any big events in the past couple of years there?
None this year. We had 2 huge ones last year where again, it was very quick. The cold air got locked in the gorge, and we had 3 inches of freezing rain and sleet. And so what happened was, well, so you're forecasting 1 to 2 inches of freezing rain. And of course that's like, okay, do we want to do that? You know, that's a committee meeting, by the way. When that happens, if you're the forecaster on duty, you are not making that call on your own. Even me, the chief meteorologist, I am not making the call on my own. I need other people to corroborate and agree. So we'll do that. What was happening with that ice storm, we were actually lucky. The first the first inch that was falling was fun, and power lines are actually about 100 meters off the ground. So at 100 meters, it was sleet. By the time it got to the road surface, it was freezing rain. So it was bouncing off the power lines and landing as freezing rain on the road surface. So the road surface got 2-3 inches of freezing rain. The power lines actually got off relatively okay. We had very little power line damage. We had huge substation damage, which we didn't even think of that. So yeah, you can get that kind of ice. It's unusual, obviously, but so yeah, and that was, I forgot the dates last year that happened, but yeah, it was a long couple of days. So yeah, we can get those. And usually the gorge itself, Eastern Washington, they usually go from snow right to rain. And Portland itself, it's actually a very interesting thing because the east side of Portland is near the mouth of the gorge. They tend to be quite a bit colder than the west side of the city. So we end up with east of I-205 freezing rain, west of I-205 rain. Seattle doesn't have as much of that problem because one, there's no gorge in there. And they're also right along Puget Sound, which is pretty, I mean, unlike Portland, which is inland, they're right near that warmer water. So it's really hard to get freezing rain in Seattle. But when they get, I mean, their bigger issue is that they're hillier than Portland. So if they get 3 inches of snow, it cripples them. Portland, we can actually kind of take 3 inches that will close the schools, but it's not terrible. Like Seattle, 3 inches of snow, they're not going anywhere. So. Anything Western interesting. I will say this, by the way. Actually, let me, now that I think about it. Of course, I'm going to get, never mind. Let's see, what do I do? All right, fine. I just wanted to show how. Okay, so these numbers, oh, okay, this is cool. 2 weeks ago, these percent of snowpacks for granite for northern Great Basin, so here's the Truckee River, was around 40%. This last 2 storms have increased them to 72%, 68%, 76%. So one of the big things about California that's really interesting is when they get a storm, if you get 2 or 3 good storms, especially earlier in the year, they can make up deficits in a hurry. But we still have some points at 5,000 feet. They have 0 snowpack, 2%, 11%. So they're not in great shape, but these past couple of storms have definitely helped. But this is about 20% of average 2 weeks ago. Now they're up to 50. and they're going to get quite a bit more here in the next 36 hours, 48 hours. So they're looking better in California than they did before. But we watch them very carefully because if they don't have a snowpack, they can't generate electricity with them. And now they have natural gas, wind, and solar. And eventually they have to buy their power. And guess who they're going to come to? Because they've got carbon taxes in California. They're going to come to any source of energy that's green and, oh, we'll sell you some power. So we watch this carefully because that's how we're gaining, I wouldn't say gaming, but we're keeping an eye on their power supplies so that we can sell down there and figure out how much we can sell down there and how much they might need going into the spring and summer season.
Eric, I missed that. So how's the snowpack related to the renewable energy in California?
Great. So in California, just like in the Pacific Northwest, there's several most of the dams are for flood control, but there's usually power plants on them, generators. So if you've got a nice water supply, you can generate electricity. You can generate more electricity during the spring and summertime that you can balance against your wind and solar. So they'll generate at night. The solar and wind will generate during the day, win-win. If you don't have that power, if you can't generate at night, or you have to generate less because you got to save your water for irrigation, which is the other need that they have, they can't generate as much power, particularly at night, and energy prices start coming up at night. Well, wind and solar, well, wind might blow at night, solar's not going to generate at night. Now you got to bring in power from somewhere else. And it'll either come natural gas, but that's, that produces carbon emissions, or hydro. In California, there are no coal plants anymore, and there's only 1 or 2 nukes. So if you want to stay green, you got to buy hydro.
Okay, thanks.
Yeah. I think that's about it.
Yeah, any other final questions for Eric? All right, round of applause for Eric. Yeah, thanks for coming out. And next week we'll have Dr. Bowley for the presentation.
Great.
But,